Hi everyone! Today we're going to study vectors and linear equations. Let us do a review here. A vector in the xy plane is an ordered pair xy of real numbers that can be represented as a column matrix xy. Also, a vector in the space is an ordered triple xyz of real numbers that can be represented as a column matrix x, y, z. Let us define linear equation. An equation that has the highest degree of 1 is known as a linear equation. A linear equation with unknowns x sub 1, x sub 2, x sub 3, up to x sub n can be written in standard form as a sub 1 x sub 1 plus a sub 2 x sub 2 plus a sub 3 x sub 3 plus up to plus a sub n x sub n equals b, where a sub 1, a sub 2, a sub 3 up to a sub n are constants called the coefficients, and b is called the constant term of the equation. A solution of the linear equations is a list of values for the unknowns, or equivalently can write as vector. Example 1. Consider a linear equation in three unknowns x, y, and z. We have here x plus 2y minus 3z equals 6. In here, x equals 5, y equals 2, z equals 1 is a solution of the equation, because if we substitute these values in our equation here, it will satisfy the equation. So the x here becomes 5 plus the 2y, we write it now as 2 times 2 minus the 3z becomes 3 times 1 equals the constant 6. So the 5 plus the product 2 times 2 is 4 minus the product 3 times 1. So we have here 5 plus 4 minus 3 is equal to 6. We can see that 6 equals 6. We can write the solution as vector u, and this equal to 5, 2, 1. Or a column matrix U equals 5, 2, 1. On the other hand, the vector W equals 1, 2, 3 is not a solution, since on substitution we do not get true statement. Let us substitute. The x becomes 1 plus the 2y now becomes 2 times 2 minus the 3z is 3 times 3 equals 6. But we write here not equal to 6 because this is 1 plus 2 times 2 is 4 minus 3 times 3 is 9. So this is 1 plus 4 minus 9 is equal to negative 4, which is not equal to 6. We go now to system of linear equations. Consider a system of linear equations, and this is the form. You can pause the video and analyze this form. Also, we can express this system in vector form as follows. So we have x sub 1 multiplied by this column matrix. First element a sub 1, 1, a sub 2, 1 up to a sub m1 plus x sub 2 multiplied by this column matrix. And this is A sub 1, 2, A sub 2, 2, up to A sub M2. This pattern follows up to this X sub n times the column matrix A sub 1n, A sub 2n, up to A sub mn. This is equal to this column matrix for the constants. We have B sub 1, B sub 2, up to B sub m. Now, for linear combination, we can represent this vector form into like this. X sub 1 times the vector u sub 1 plus x sub 2 times the vector u sub 2 plus x sub 3 times the vector u sub 3 plus up to this x sub n times the vector u sub n is equal to the column matrix for the constants can be represented as vector v. There is a theorem that says a system capital A times capital X equals capital B of linear equations has a solution if and only if capital B is a linear combination of the columns of the coefficient matrix capital A. Example 2. Write the vector V equals the column matrix 11, 5 as a linear combination of vector u sub 1 is equal to the column matrix 2, 3 and vector u sub 2 is equal to the column matrix negative 5, 4. Find the equivalent system of linear equations. For step 1, we're going to write the general form for the linear combination. That is, vector v is equal to x times vector u sub 1 plus variable y times vector u sub 2. Then we substitute the corresponding matrices. The vector v is the column matrix 11, 5 is equal to, we copy the x, and the vector u sub 1 is given here as 2, 3 plus variable y times the column matrix given as negative 5, 4. We can multiply this x with the matrix. So we have 2x, 3x respectively for the first matrix plus negative 5y, 4y for the second column matrix. Then we can add the two matrices on the right. So we have now 2x minus 5y, 3x plus 4y. With regard to the equivalent system of linear equations, we have this 2x minus 5y equals the constant 11. And the second equation, 3x plus 4y is here equals 5. This is now the equivalent system of linear equations. Now, for step 2, we're going to solve the values of x and y. Let us copy our equations in here. Then we can solve this using the methods we are familiar with. We can use elimination, substitution, or by matrix. In here, we can solve using elimination. We can start by eliminating the variable x. We can see here that the coefficients of the x are different. So what we do is to multiply the first equation by the coefficient of the second equation. So the first equation we multiply by 3 and the second equation we multiply by this 2. So the first equation now becomes 6x minus 15y equals 33. The second equation is 6x plus 8y equals 10. We have here 6x positive and another positive 6x in the second equation. To eliminate this, we're going to subtract. Getting the difference now, we cancel the 6x and 6x. Negative 15y minus positive 8y is negative 23y equals 33 minus 10 is 23. And from here, we can get the value of y as negative 1. To get the value of x, let us take any of this equation. Let us substitute the value of y as negative 1 and we will solve for x. Let us use now the first equation. So this is 2x minus 5 and the y becomes negative 1 equals 11. We can simplify this negative 5 and negative 1 to be positive 5. And this positive 5 we can transpose on the right side 11 minus 5. So it becomes 6. So the value of x here is 3. And from here, we will substitute the corresponding values x and y in our linear combination form. Thus, the final answer will be like this. I hope you learned something from this video. See you again next time.